On your worksheet, putting it all together, we have an application problem. A grapefruit is launched straight up in the air with an initial velocity of 95 feet per second. The grapefruit's height or position after t seconds is modeled by our function. Our first step in part A is to graph the function in a standard viewing window. We've done this under Roman numeral 2 in the past, so if you need more clarification, you can always review back to the Roman numeral number 2, graphing and window adjustment, and its video. All right, so to enter the function, we start by going to y equals. If you have any other previous information or functions that are in there, you'll need to hit clear and clear them out. And we're going to go ahead and hit our function, or type in our function. We have negative 16. Make sure you use the negative key. And then 16. Now our function is in terms of t. Please remember that we are going to be using our variable key, and you can find that with xt theta n. We use that whenever we're going to enter a variable, and it will be entered as an x, but it's the same representation as our t. And then finish it out, x squared plus your 95t, which we're going to go ahead and use our variable again. Now when we first graph a window or graph a function, we're going to go to zoom and go to option 6 for our standard window and see if we can see our function. Right now, when we first look at it, we can only see part of it. What we can see is we've got two different pieces of this function. This is a negative 16t squared, so we do have a parabola opening downward, but we can't see the top of this parabola. We now have two different options. We can go to window and adjust the window to see if we can see it, or we can go to table, so you'd have to hit second table to give us a better indicator of how big we could make it. I don't want to play guess and check, so let's go to second table and see how high does this vertex actually go. When I look, it goes up to at least 141, and then it starts coming back down. What that does is it gives us a good indicator on our window. We need to make this graph go higher, so that's the y axis. We need it to go up, and maybe we'll try for like 150. Go beyond what those table values were. And then if I enter graph, there is my entire parabola. Don't worry too much about this solid bar that shows up. What is happening there are when we were in window, you can see the scale, and it is entering a tally mark on our y-axis every single unit. So it's got one at 1, 2, 3, all the way up to 150. If that bothers you, and only if it bothers you, you can go down to your y scale, and maybe instead of counting by ones, I count by tens. It will not change the shape of my graph, but it will change that now on my y-axis, we are counting by 10, 20, 30, 40, 50, and so on. It's just a matter of preference, whether you want to or not. So we graphed our window, or we graphed our function. We tried it in a standard viewing window and could not see it. So now we went to adjust our window, and now we can see the entire graph. So part B, when will the grapefruit reach its maximum height? Well, the maximum height will occur at this vertex. We don't want to guess though. We want an exact number. So just like we did back in Roman numeral number 4, we are going to go with our second calculate and choose the maximum option. So your second calculate, we're going to need to calculate a maximum. Now, remember, when you calculate this maximum, it's going to ask you basically which domain do you want us to find that maximum in. Now, to move your cursor along your curve or along your function, you're going to have to arrow left and right. Arrowing up and down will not move the cursor. What that would do, if you had a second function on the same screen, the up and down arrows would toggle you between your two functions. We only have one function. That's why it appears not to have done anything. So if I want to go further up, I would actually go to the right in my domain. So I'm going to get closer to the top. Notice the calculator is asking me, is this the left bound? So am I to the left of my maximum? Yes, I am. So the way I tell my calculator yes is I hit enter. Now I need to go and find the right bound. So I go to the right of my maximum, and anywhere beyond it is fine. And I need to tell my calculator, yes, this is the right bound of where I want you to look for a maximum. Hit enter, and then you can go ahead and take a look. Is your maximum in between these two bounds? Yes, it is. So I'm going to tell the calculator yes by hitting enter again. And it calculated a maximum that happens at an x value, or an input value, of approximately 2.97. The output value, or y value, occurs at approximately 141.02. Now, going to our question, part B, when will the grapefruit reach its maximum height? Remember, our input was originally our t, or our time. So our independent variable, or our x values here, represent time. So when I go to answer question B, it would be, the grapefruit reaches a maximum height at approximately 2.97 seconds, because our original problem was in terms of seconds. For problem C, what is the maximum height? If you remember the original problem, our output value, or our dependent variable, our y value, represented height. So our answer to problem C is the maximum height is approximately 141.02 feet, because the original problem was in terms of feet.